Hello, fifth grade. Back again on day two of being at home. Hey, Mr. Godovic, our superintendent for South Park, put out an email today saying that we're going to be home, or you guys are going to be home for the rest of the week until at least Monday. And we can come back to normal school. So I saw the building today. There are a bunch of guys in there working, getting it ready. For those people who are thinking about careers, keep in mind the world will always need electricians. The world will always need plumbers. No shame in doing those two trades or any type of trade whatsoever. I walked into school this morning and saw a whole bunch of hardworking men, and there are some women doing some trade work in the building. So make sure that you don't rule out your union trade jobs as careers. Carpenters, electricians, plumbers, steam fitters, those jobs are available, and the world will always need those type of tradesmen. So and tradeswomen. So no shame in those careers. Just think how many sinks you have in your house, how many toilets you have in your house. Eventually, they're all going to either need to be replaced or repaired. Who do you call a plumber? So keep in mind, those are always great careers to look into. So today's lesson, it's going to be a decent one. We're going to be talking about matter and mass, and we're going to be working up to an experiment that I'm going to do on the computer with you guys on Friday, and you guys can do it at home with your parents over the weekend. So if you're there with your mom or your dad, good morning from fifth grade. If you're there with your grandparents who are babysitting or your babysitters, good morning to you guys also. And just kick back and follow along. Once again, whenever you go to take your paper notes, I will highlight everything, and you can just write it down. Make sure that you're skipping space between notes. So I want a clean sheet of paper, and we'll put everything in your notebooks neatly. And the title I want at the top is Matter, Matter Everywhere. Once again, right at the top here, Matter, Matter Everywhere. All right. Very first sentence. All substances in the universe are made up of matter. Very first sentence is important. How do you know it's important? Because I just put it in blue. So go ahead, take your time, write it down word for word. The very first sentence, all substances in the universe are made up of matter. Please put that one down. All right, moving right along. Next thing I want you guys to look at is, believe it or not, the second sentence is pretty important also. Matter describes anything that has volume, meaning it takes up space and has mass. So once again, we're going to skip at least one line between the first note and the second note. Once again, that little blue dot comes up, so let me get it out of the way so it's not blocking anybody. There we go. Matter describes anything that has volume, meaning it has mass, it takes up space and has mass. So we're good to go right there. If anyone's paying attention today, I'm wearing my Waynesburg volleyball t-shirt today. Supporting the Hornets, or not the Hornets, the Yellow Jackets of Waynesburg University, right down the road, right down on 79. All right. Mitch took a visit there not too long ago, and I grabbed his t-shirt while I was down there. All right. So we have the first note, the second note, note number 3. And remember, if you're with your grandparents or mom or dad, if we're going too fast, just pause it, Finish the note. You already know what it is because it's in blue, and write it down. Here we go. Mass is the measurement of how much matter something contains. Highlight it. You know those little dots are going to show up. Oh, they're not in the way this time. Mass is a measurement of how much matter something contains. All right. Hey, one thing that might have been a problem for you guys today as you're writing it down is taking the online attendance. I knew it was going to be a nightmare because I have like 4 or 5 homerooms in my one homeroom. So just try the best that you can. And if you have a problem logging in for attendance, if you're in my homeroom, just shoot me an email and I look at it every 4 or 5 minutes. I know a couple people emailed me today and I got back to them rather quickly. One thing I had on yesterday's lesson is to call my room. Unfortunately, I can't get anywhere near my room because of the damage. So actually, I'm in the LGI or the library. So if you have any questions, go ahead and email me and we'll be good to go. All right. So the third note, mass, is the measurement of how much matter something contains. There we go. Oh. And obviously in this picture, I hit it accidentally. Here's an elephant. It has more mass than a little mouse. All right. On Earth, hang on. There we go. I get those little blue dots out of the way there. I know this is a long one, so go ahead and put it down. On Earth, mass is measured in units called grams. An elephant has more mass than a mouse because the elephant contains more material. Does everybody understand? I know that's a long one, so go ahead, write it down, and this is a perfect opportunity. Hit the pause button and write it down. On Earth, mass is measured in units called grams. An elephant has more mass than a mouse because the elephant contains more matter. If you look at the lovely Mr. Lauritzen and myself, I definitely believe I have more mass than Miss Lauritzen. Miss Boda, I have more mass than Mrs. Boda. Mr. Scobie and myself, I think he got a little bit more mass than I. But don't tell him I said that. All right. I'll read that one again. On Earth, mass is measured in units called grams. An elephant has more mass than a mouse because the elephant contains more matter. All right. The next sentence down, I'm just going to scroll up a little bit. What has more mass, a giraffe or a bumblebee? Generally, bigger items have more mass than smaller items. So the giraffe would. So it's very simple. If you look at, if you take myself and let's say we take Fiona Brown, I'm obviously way bigger than Fiona. I have more mass. If you look at Mr. Lev upstairs, I'm bigger than Mr. Lev. You know, I'm 6'2", 285 pounds. So I have more mass than Mr. Lev. But every now and then you do have a situation, which I'm getting ready to read, where the smaller object has more mass than the larger object. Here's an example. What has more mass, a giraffe or a bumblebee? In this case, it's going to be a giraffe. Generally, bigger items have more mass than smaller items, so the giraffe would. However, there are exceptions. A small iron statue has more mass than a large rain cloud. So I'm going to put that one down right here. And I want you to put a star right beside that one on the side of your notes. A small iron statue has more mass than a large rain cloud. Put that one down. Hopefully everyone's taking advantage of these couple extra days. It's spending time with your family, getting work done, cleaning your room, helping your parents, help the house, clean the house. Unfortunately, there's no snow on the ground because this would be great to have snowball fights or go sled riding down its sunny slopes. But hey, who's going to complain? Tuesday tomorrow, I'm actually making this Monday night. Tuesday tomorrow is going to be 62 degrees. Who's going to complain about in the 1st of January in the city of Pittsburgh, it's 62 degrees? I definitely won't. All right. Remember, after every note, we want to skip a space. A small iron statue has more mass than a large cloud. All right. Real quick one. What about air? Is air made of matter? To figure out this problem, you need to determine whether air has mass and takes up space. Because air is made of gases, it looks like it is not made of matter. However, imagine two balloons. Imagine you have two balloons and filled one up with air. Which balloon do you think has more mass? The one with the air in it would. The fact that you can inflate the balloon also proves that air takes up space. Air particles may spread out and be too small to see, but they do take up space and give the air mass. So, let me move this out of the way to get that out of the way here. All right. What I want you to do right here is, let me see. I want you to take this note down. Oh, there we go. All in blue. There we go. The fact that you can inflate the balloon also proves that air takes up space. Air particles may be spread out and too small to see, but they do take up space and give the air mass. All right, so go ahead and put that down. All right. If you need more time, just pause it. I know that's a longer one. Now, and as you're writing, just do me a favor on Friday, if you can, have your parents get something called corn starch. Corn starch. It's in any grocery store. Walmart has it. Giant Eagle has it. Aldi's has it. Shop and Save has it. It is in the baking aisle. Normally it's right beside either the baking soda or the flour. Mom's, dad, if you can, grab a box. It's $1.50, $1.60 for Friday's experiment. If you want to follow me, all you're going to need is water from your sink and a box of cornstarch. We're going to look at an experiment that looks at solids, liquids, and gases and how things react. All right. Now let's go ahead and look down at these questions right here. What is a measurement of how much matter something contains? Is it length? Is it volume? Is it width, or is it mass? Everybody, it's mass. Which animal has the greatest mass? A panda, a rabbit, a snake, or a whale? Obviously, it's going to be the whale. And the next question, what has mass and volume? Gravity, temperature, time, or matter? And it's obviously matter. All right. So that's today's lesson. See you guys on Monday in person. Hopefully, cross your fingers. If you can, grab that cornstarch by Friday so you can have it for the experiment. You can just follow me along. It's not dangerous. It's not difficult. And hey, I'll see you tomorrow with another video. Just keep checking the YouTube channel. Go to my Canvas page, and it's just want to say go to the YouTube channel. All right? I'm gone. See you later. Hey, as always, go Eagles.